Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter minimal polynomials and minimal equation of a matrix, lecture number 1, in which I will give some basic concepts which will help to understand the contents of the chapter. Firstly, we define the term non-zero polynomial. Here we have a polynomial fx equal to a naught plus a1 x plus a2 x square plus plus a n x to the power n. Here coefficients of the first term is a naught, coefficient of second term is a1, coefficient of third term a2, and coefficient of last term equal to an. Now we define non-zero polynomial. A polynomial fx equal to a naught plus a1 x plus a2 x square plus plus a n x to the power n is said to be a non-zero polynomial if the coefficients of various terms are not all zero. It may be possible that coefficients of some terms may be zero, but coefficients of various terms, means all terms, are not equal to 0. Now we define the leading coefficient of a polynomial. The leading coefficient of a polynomial is the coefficient of the highest power of the variable of the polynomial. For example, here we have a polynomial fx equal to a naught plus a1 x plus a2 x square plus plus a n x to the power n. Here variable be x and highest power of the variable is n. So coefficient of the highest power of the variable is an, and so an be the leading coefficient of the polynomial. Now we define the term a polynomial annihilates a matrix. Let fx equal to a naught plus a1 x plus a2 x square plus plus a n x to the power n is a polynomial of degree n, and let a be a square matrix such that f a in place of x we write matrix A, square matrix A. Here A naught, here coefficient is 1. We write here in term of matrix, unit matrix I plus A1. In place of x we write A. Here in place of x we write A. Here in place of x we write A. And if this is equal to a zero matrix, then we say that the given polynomial, this polynomial fx, annihilates the matrix A. For example, let A be a square matrix, then determinant of A minus lambda I be the unit matrix, equal to minus 1 to the power n under bracket lambda to the power n plus a1 lambda to the power n minus 1 plus plus an is the characteristic polynomial of matrix A. Therefore, characteristic equation of matrix A will be determinant of A minus lambda I equal to 0, implies that lambda to the power n plus a1 lambda to the power n minus 1 plus plus a n equal to 0. Let function of lambda, f lambda equal to lambda to the power n plus a1 lambda to the power n minus 1 plus dot 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 plus an. Then function of lambda equal to 0. The Carey-Hamilton theorem states that every square matrix satisfies its characteristic equation. Therefore, function of A, matrix A equal to 0 matrix implies that in place of lambda we write a to the power n plus a1 a to the power n minus 1 plus dot 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 plus an. Here we have coefficient 1. Here we write unit matrix in terms of matrix I equal to 0 matrix. Hence, the characteristic polynomial f lambda of a matrix annihilates the matrix A. Therefore, we get that at least one non-zero polynomial. That polynomial is characteristic polynomial annihilates the matrix. So, set of non-zero polynomials which annihilates the matrix is non-empty because we get at least one member. That member is characteristic polynomial which annihilates the matrix. Number 4, we define monic polynomial. If the leading coefficient of a non-zero polynomial is unity, that is, the coefficient of the highest power of the variable of the non-zero polynomial is unity, then the polynomial is said to be monic polynomial. For example, here fx equal to x cube minus 2x square plus 5x plus 3. Here leading coefficient equal to the coefficient of highest power of x. Here coefficient of highest power of x is 1, highest power be 3 and coefficient of x cube be 1. Therefore, this polynomial is said to be a monic polynomial. Number 5. Now we define minimal polynomial. If we collect all non-zero monic polynomials which annihilates the square matrix A, then among these non-zero monic polynomials, the monic polynomial having the lowest degree is called the minimal polynomial of the matrix A. Means a monic polynomial having the lowest degree which annihilates the matrix A is called the minimal polynomial. Next we define minimal equation of a matrix. If fx, function of x, be the minimal polynomial of a matrix A, that means the monic polynomial fx annihilates the matrix A, then the equation fx equal to 0 is called minimal equation of the matrix A. All these basic concepts will help to understand the next theorem contents of this chapter. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.